Alright, boys and girls, welcome back to the drive-thru, forging forward with 2.7 radical ideas. Notice there's a picture of Einstein here with this E equals mc squared, and in this case, the squared is the exponent, okay? So, Tia and Tahani know that A to the m over n is the same thing as the nth root of A to the m. If you have no idea what you're talking about there, I want you to think about 4 to the 1/2 power. You might want to type that into your calculator. Well, that is the same thing as the square root of 4 to the 1st. So your calculator should have given you 2. So now we have just confirmed that that works for at least that situation. Okay? So we got Tia likes to work with radicals. We know that about her, because she says she understands all of these properties. So the nth root of A to the n is A. That's like this. The square root of 5 squared. Well, I mean, maybe you want to write out 5 squared is 25 and the square root of 25 is 5. You can think about this and this canceling each other out, okay? The nth root of A times B is equal to the nth root of A times the nth root of B. Let's practice another one. What's the square root of 4 times 25? Well, what's 4 times 25? 100. So we know that the square root of 100 is 10. But let's use the rule. That should be the square root of 4. Keep in mind, we don't need to write the 2 here because mathematicians are lazy, so they've just started writing that as this. Well, what's the square root of 4? 2. And the square root of 25 is 5, and that indeed equals 10. So that one works. And I won't do an example, but this is what that's all they're doing. They're just showing you that these things work. In this case, A and B are just numbers, and n is a positive number. Okay, so Tahania, she prefers exponents. So there are 5 rules for exponents. No, 6. So look, A to the m times A to the n, that's A to the m plus n. What? Well, think about it. What is 2 squared times 2 to the 3rd? Well, that's 2 times 2, and this is 2 times 2 times 2, and that is 2 to the 5th. So yes, we did just add the exponents. Okay, I'll give you one more example for number 2. What is A squared cubed? Well, that's A squared times A squared times A squared, and that is A to the 6th. So, if you are taking an exponent to another exponent, you multiply those two numbers. Okay? So, take note of the rest of these. You're going to need these rules. This one's kind of important too. A to the negative n, that's 1 over A to the n. So it says, do this. Illustrate with examples and explain, using the properties of radicals and exponents, why A to the 1 over n is the same thing as the nth root of A, and A to the m over n is the same thing as the nth root of A to the m power. Well, let's use an example. So let's do 25 to the 1/2 is the same thing. That it's equal to 5. If I put that in my calculator, go ahead and put it in the calculator, pause your video. Well, that's the same thing as the square root of 25 to the 1st. So that works. How about, let's see, 4 to the 2/3 power. Sorry, I hate this new system. 4 to the 2/3 power. Well, let's put that in our calculator. 4, oops, turn it on. 4, turn it on. 4 to the parentheses 2/3, close it. Alright, that's what we get for it. It's 2.5198. It's about equal to 2.5198, okay? Well, we also know that that is the cube root of 4 squared. Well, what's the cube root of 4? Oh, let's see. Cube root. Well, we're just going to have to do it 4 to the, this is how you do cube roots on a graphing calculator, 1/3 power. Okay, now if we wanted to take that result and square it, boom, you get the exact same result. So we have confirmed it. Okay? I don't love this right here, so don't worry about it too much. But basically, they're saying that Tia likes to use exponents, and Tahani prefers to use, I'm sorry, Tia prefers to use radicals, Tahani prefers to use exponents. Don't even worry about that. We just want you to know there are two methods to do this. So if we wanted to simplify the square root, keep in mind this is a square root. There's no 2, whoops, there's no 2 there, but there really is. It's an insinuated 2, okay? So the square root of 27, we don't want it as a decimal. We want to simplify it. So that could be, you can consider that the square root of 9 times 3. And that is the square root of 3 squared times 3. Remember, there's a square root there. Well, look, one of the rules we learned was that cancels. So now we can take that 3 and put it out here, and we would write that as 3 times the square root of 3. Okay? Another method might be 27 to the 1/2, which is 9 to the 1/2 times 3 to the 1/2. 9 to the 1/2 is 3. 3 to the 1/2 is the square root of 3. You get the same thing. This is certainly my preferred method. Okay? What about the cube root of 32? Well, 32 is 2, 4, 8, 16. 2 to the 5th is what 32 is. Sorry about my crappy equal sign, but what you really should be sorry for are these crappy ViewSonic boards. 2 to the 5th is 32. Okay? So this is the cube root of 2 to the 5th. Well, we can write 2 to the 5th, if you know our exponent rules, as 2 cubed. Look, why did I choose cubed? Because those are going to cancel. 2 cubed times 2 squared. Look, boom, boom. Pull it out. You get 2 times the cube root of 2 squared, or 2 times the cube root of 4. So that is how you simplify that. Don't worry about two methods. Just be able to simplify it. Okay? You're going to need help with this. I'm here to help. Hopefully this gives you an introduction. Hope it helps. Boom!